Hi, Gary. I'm going to pause the record or in the WhatsApp is fine, but we really do appreciate the feedback. We know a lot of you already have had not just exposure to noise, but exposure to this content. So we would like to know what you think. Is it still useful for you? Is there more advanced training that you would like to have? We'd really appreciate all that feedback. Now, Miriam was going to join us. She has just had a communication in the WhatsApp group about if you can't join, especially for people who are having internet problems, please send an email, because if it's in the WhatsApp, we may not know exactly who you are. So if you cannot join for some reason, and you plan to view the recording of the session, please send an email to whwbtutors@gmail.com to let us know. So thanks very much. And with that, I did want to tell you that the first part of this session will be taught by Gary Bangs. And then we will do the breakouts. This time we will do the breakouts in a different way. We'll do it in the middle of the class, and we'll have the breakouts, and then we'll come back, and then I'll finish up the course content. So with that, I'm going to turn it over to Gary.
Okay. Marianne, can you help me with the whiteboard? Okay,
Yes, I will launch the whiteboard.
Okay.
Yeah.
Okay, I'm going to go ask for everyone's forgiveness as I see. Are you seeing my screen yet?
Yeah. Well, oh, you want to do it now? Okay. Yeah. Or did you want to?
Well, we're gonna.
Do you want to do the whiteboard now? Okay.
Well, let's see. We'll get the. We're going to introduce the. Can you see my screen?
Yes.
Okay. So before the whiteboard, just the introduction, the overview of today's class, measuring noise. We talked a little bit about the physics of noise, and we're going to continue that conversation today about some basic concepts and in measurement, and then how we measure it, why we measure it, some technical aspects and some practical aspects. We'll do some calculations, or Marianne will help you with doing some calculations, and hopefully we'll get some feedback from you about how you, if you've already been doing noise surveys, what you've been doing, and maybe some tricks or some questions. So that'll be a good, that'll be in the second half of the session today. So we wanted to ask everyone a quick question. We'll put up the whiteboard, and what is your role regarding noise surveys? In other words, do you do noise surveys? Does someone else conduct noise surveys? Maybe you think you need a noise survey at your workplace, or maybe you are managing and interpreting results or teaching classes. So we'd like to know the answer to that. And Marianne or Mariam, you want to put up the whiteboard? I need to stop sharing. Okay, there we go.
Automatically stops sharing. If you cannot use the whiteboard, you can comment in the chat as well. So I think everybody knows the routine from last time, I hope. To type text, click the T that's on, at least on my screen, on the right, or you can draw something or write something with the pencil icon. So we'd love to hear from you. What is your role in noise surveys?
Okay, some people are doing them themselves, and I see there are other people who are dedicated to an occupational hygienist is doing it.
So
And
here's the question. sorry, go ahead.
Go ahead.
I have a sort of supplementary question. If you don't do them yourselves, do you still have to interpret the results? I see somebody said, I do noise surveys and interpret the results. Review the report. That's just, yeah, what I wanted to hear. You review the report and connect with audiometry to see. I'm trying to make that box bigger so I can see the rest of your answer to see if it's noise-induced hearing loss. Okay. And in the chat, it says, propose the occupational monitoring program, review the report of the results and propose controls. Terrific. Okay, that's great. That's just what we kind of want to know. One of the things we will ask later in the class, if anybody needs a sort of a special session about using, say, sound level meters and noise dosimeters and how to interpret the results. So this really helps us. Okay. Surveys done by an external service provider. It is for me to interpret. Okay, excellent. Good. That's very good to know. Okay, great. Okay, so I think we can close the board now, but if anybody has more comments along this line, please put them in the chat. And this is very helpful. Thank you all very much for this feedback. So I'm going to close the whiteboard now and Gary can continue.
Oh, that's the part of this class that I enjoy, is the networking and sharing and learning about all you do. Like at the beginning, before we came on today, we had some good conversations. All right, so let's see. Here we are. And I'm just going to make my screen. There we go. So last time, as I said, we talked a little bit about the physics of noise. And so we're going to continue that thought. And noise is essentially energy. Okay, it's a form of energy radiating out from a source. And as it radiates out, it's like, if you imagine a bubble or a balloon that gets thinner and thinner, the further out it goes, the bigger it gets. Well, this illustration here shows you that the energy is spreading out. And so, of course, you have less energy per square unit, okay? And noise is this bubble of energy that's spreading out. And how we measure it depends upon what we want to achieve. So engineers are going to be interested in, making a car more quiet, perhaps, or a machine, or protecting people from noises. So forms of insulation. So for that, they want to know the energy, and they're using units in watts or joules per second. Okay, and that's expressed also per surface area, like in the illustration. For us, we're focusing on the effects on the human ear, the eardrum and middle ear, and and hearing ultimately. So we're measuring pressure. We're not focusing on the power or intensity, but what is the pressure and relative to atmospheric pressure. And if you remember last week, we were talking about the waves of sound, like waves in the ocean that are propagating through the air and striking against the eardrum. So that's what we're concerned about. Now, the range of sounds that we can hear is huge in terms of pressure, in terms of air pressure. So the least that we can detect with our ears is 20 micropascals, and the most is 20 million micropascals. And that range is very unwieldy. It's hard to talk in terms of hundreds of thousands of units. And so, like many things in the natural world, they lend themselves to expression in log scale, in either natural log or log base 10. It turns out that sound lends itself to log base 10, so powers of 10. So then, instead of 20 to 20 million, we have 0 to 120 decibels. And are there noises greater than 120 decibels? Of course there are. So what is a decibel? From the Latin, deci, 1/10 of a bell. Okay, so a unit. It's a unitless expression of measurement, and it's based on the actual noise pressure relative to the baseline, which, as we said, is 20 micropascals. Meanwhile, engineers are going to be measuring things in watts. Okay, so they use different terms than we do. Pressure, power, and intensity. So 3 different things that are being measured. And it's all, what we're doing is we're referencing the minimum hearing, like when you rub your fingers together or pass a feather over your ear. So the smallest amount of noise that you can hear, a tiny bit of pressure on your eardrum. So this is an illustration of the scale. So 200 million micropascals, it's 140 decibels. So for ease of use, the decibels are much more convenient, and also for expression in math and for regulating noise exposure. So we usually think of what we're dealing with day to day, a quiet office and somewhere around 40 or 50 decibels up to about 80 or 90 decibels, depending on where you are. Okay. Now, how do we perceive decibels? How do we perceive noise? Well, every 10 decibels, the power of pressure increases by a factor of 10, but we perceive it as twice as loud. So we can't really interpret just using our ears how much pressure is hitting our ears as well as we can by measuring it. So if you go from 0 to 20 or from 20 to 40 decibels, it's 4 times louder to your hearing. And if you go up from 20 to 60, it's 16 times. So 2, 4, 8, 16, 70 would be 32, right? So, and then another 10 decibels, doubling again to 64. So that's, we think it's 64, but it's actually 10 times 10 times 10 times 10 times 10, 8 times, okay? So what terms do we use to express our measurements of noise? So the A-weighted level in this expression, LA equivalent, so across the time period that we are measuring. So if you measure for 4 hours, this would be the level of sound, which is the L. The A represents the A weighting. And so it's, in other words, it's emulating the human hearing. And the EQ means it's the time period that it was measured. Now, if you want to determine the average or the exposure over a particular work shift of 8 hours, similar to a time-weighted average, we don't say time-weighted average, but we use the L subscript EX for exposure time, okay, the allowable exposure time, and in this case, 8 hours. So this is the expression that we use. If it was 10 hours, it would be subscript 10, okay? And we keep using the term average, and I know some of you might ask about that, because you have to mathematically average the log scale. So it's a little more complicated than just taking the average or the mean. Okay. So this term, the L subscript exposure, is very important if you have a regulatory limit where you live or where you work. So we can express whether someone is exposed above or below their regulatory limit. Okay, so again, the LEQ is going to be over the time period. What was the average exposure over the time period? And this kind of graphical representation is great for showing people, what we're doing in terms of measuring their noise exposure. So they might be in a noisy place represented by a peak, and then a quiet place, a noisy place, going from one work area to another. And then what was the equivalent to a continuous, if they were exposed continuously, what would be the equivalent for that time period? Now we're going to talk about a few more concepts. Before we get into measurements, we want to have some common language. So the exchange rate is something you need to know for using your noise dosimeters, your sound level meters. It's also called the doubling rate. And this relates to the regulations in your country, or as I said, in your particular workplace. Okay. So what is the standard that you use to represent a doubling in the noise? And that is commonly through most of the world, 3 decibels. So if 10 decibels is a power of 10, then logically 3 decibels is about double. Okay, as you go from say 80 to 83, that's about twice the power. So it's working your way up to that 10. All right. And that's more mathematically accurate than what the US OSHA uses, which is 5 decibel doubling or exchange rate. Continuing with the terminology, we talk about a dose relative to a particular standard. So are you allowed to have a certain amount of noise exposure? And what is your dose? Okay, so when dose is represented, it's a proportion, and we represent it as a percentage of your allowable exposure. You set your meter to slow or fast response time, and that slow response time is going to, in other words, those very fast peaks will be sort of smoothed out, okay, so because it's not going to respond as fast. A fast meter, fast setting on your meter will pick up more of those peaks. And a criterion is what I've been talking about. It's another word for the permissible level, okay? What is the level? What is the limit for the noise exposure that you can have? Okay, so maybe 85, very conservative, might be 80. In the US, it's 90. So that's our cutoff above which you need hearing protection or hearing conservation program. The cutoff or the threshold is another term that's going to be useful when you're using the sound level meters and the dosimeters, because if you have a cutoff, the machine will not include in its average any sounds below that level. Okay, so anything less than say 70 decibels or 75 decibels will be ignored. Now, mathematically, that doesn't make a huge amount of difference, but scientific research is pushing that limit of what is considered hazardous noise. It keeps lowering that exposure limit. So if you don't have to set a threshold, don't. That's our advice. Just leave it at 0 so that it picks up the monitor, the sound level meter will record all of those sounds. Now the dose, again, just to repeat, as a percent of exposure relative to permissible limits. So one standard is the ACGIH, which is a non-governmental group. It's an independent group of scientists and occupational hygienists who get together and set standards based on epidemiology, based on toxicology, and so on. Standards for chemical exposures, lifting standards, and noise standards. The unusual thing is that the noise standard, they say, is not going to protect everyone completely over 40 years of work exposure. It's only going to protect the average person against exceeding a 2 decibel loss in their lower frequencies of hearing. One reason that might be is high frequency hearing loss occurs naturally as you get older. So that may be one reason why they are focused on the sound frequencies that you might hear occupationally. And again, we talked about how low can you go, and the World Health Organization says that sounds as low as 70 decibels may impact your hearing. So keep it low. So this is kind of a working through exposure limits. So if you have an 85 decibel exposure limit, you may be exposed to that level for 8 hours, and it's expected that that will not impact your hearing, given that you're going to have 16 hours away from that noise. That's the assumption. Now, if you go to a rock concert, that might not be the case. Okay. And you come into work with your ears ringing. So if you double that noise, remember the 3 decibel doubling, so twice as much sound pressure is 88 decibels. You may only be exposed to 4 hours for the same equivalent as 8 hours at 85. All right. And if you go up 6 decibels, you're doubling again. So half of that again, and so forth. And you can see that 100 decibels, which if you're working around, diesel engines or, some other industrial machinery, there are 100 decibel exposures out there. 15 minutes is the maximum exposure for the day, beyond which you may not have recovery of your hearing. Those hair cells may be lying down and not popping back up. So every 10 decibels, we have a doubling in the loudness, like I said before. When you get further from a noise source, the sound pressure goes down. Just like I said with the expanding balloon, the expanding bubble, and it goes down with the inverse square of the distance. So square the distance and divide by that. An easy rule to remember is if you double the distance, the sound pressure level will decrease by 6 decibels approximately. Okay. And that's assuming You don't have multiple sources and so on. It's a little more complicated than that. And then finally, continuous noise versus impulse noise. So that's, is it a motor that's making a continuous noise? Is it something that's hammering, literally hammering, sending out waves of, very intense pressure waves of sound, okay, typically 1 second or less. And those sounds like a hammer, a rifle, and a popping, an explosion can be 140 decibels or higher. And therefore, just a single exposure can cause your ears to ring, which means it's impacting your hearing. So you may or may not have a legal limit for impact noise. And we can talk about this later, but it's kind of difficult to measure impact noise. So it's complicated. So now for the fun stuff, right? How do we measure noise? Sounds like most of you are somewhat familiar with noise measuring machinery, instruments. These sound level meters, they integrate noise. So in other words, they record noise over a period of time. Perhaps your cell phone app does or does not. So it may not. More or less expensive sound level meters may not be recording that information. You may not be able to download it and graph it, but most do. And another type that we're not going to really go into detail is, as you start to do noise surveys, you might want to reduce the noise of something, and an octave band analyzer determines where the highest noise is by frequency. So if it's a very low frequency, maybe it's a certain kind of vibration that you can dampen. If it's a very high frequency, maybe it's electronic. So it helps you to determine where that noise is coming from, for example. Noise dosimeters are extremely useful. So they're the same, in the same way that air pumps can be used to take a personal sample and to see what a worker is really exposed to. Dosimeters also tell you what a worker is really exposed to, because the microphone is sitting right next to their head, either on the lapel or on the collar or the shoulder. And so you can either wear them, some of these, you can wear them on your belt, and others you could wear on your lapel because they're very small, smaller than a cell phone. But always you want to have the microphone close to the ear. They vary in terms of quality and precision. The best, most precise is the type 0, which you may not see outside of a laboratory or research area. And then type 1 and type 2, type 3 get progressively less precise. So type 1 and type 2 are fine for field surveys to try to determine areas of noise of concern. And then there are specialized instruments that me personally, I've never seen one, but it can be used for particular types of noise. If you're engineering or you work in industry and you're trying to design machinery, or perhaps trying to measure impulse noise. It's a good example. Okay, so now, before we go into using the noise meters and noise dosimeters, we want to have a little discussion and see where we're coming from, what kind of experience you all have. Maybe I'll pause here just a second to see that we've been tracking the chats. Whoops, sorry about that. Is anybody there?
Yeah, we're here. If you want to stop sharing, then we can just see each other. What I'll do is while you're, if you want to just talk for a few more minutes, I'll find that question and I'll put it in the chat so people can then copy it when they go into the chats in the breakout rooms.
Yeah, I just
So
wanted to
there
see
were
what-
some questions, Gary. I tried to answer some of them. I think Chandra, welcome. I didn't notice you were here till now. But you might want to just look at those questions, Gary, as well.
Mhm. Mhm. Yeah, that's an interesting, there's one chat in there about, someone might have to explain it to me about the two exposure action levels. The lower and the lower and an upper. And maybe Chandra would like to give a brief explanation.
Yeah, so this is really regarding the UK regulation, the noise regulation at work 2005. And in relation to when it comes to health surveillance, it's probably more relevant to that topic. The exposure action value and exposure limit value, these are the two values in the UK legislation. And the exposure action values is again divided into two subcategories, lower and higher exposure action values. And the difference being the lower action value does not take into account the use of hearing protection while measuring the noise or assessing that. So the 80 dBA is a lower action value, whereas the upper one is 85 dBA, which is after taking into account the use of hearing protection. And then, of course, there is a exposure limit value, which is 87 dBA.
Great. That's very interesting. And I noticed in the video, if people watch that video that was in the assignment, it does refer to an action level that OSHA has in the US as well. So Gary, I don't know if you want to comment on that. We don't have that in Canada. We just have the 85 limit, but
Yeah, it's kind of an early warning concept. If you get to this level, you need to start thinking about, you know, the hazards of the workplace, and you may, you know, require start looking at noise protection, hearing protection, and then as you get progressively louder, you have to do more, like use engineering controls.
there's another question in the chat, Gary. What is the main difference between the inaccuracy between sound level meter type 1 and 2? I don't know if you have experience with that. My experience is that type 2 is usually the minimum required for any measurements related to human exposure and prevention of noise-induced hearing loss. Though when I've been asked to use a type 1, it's because they were measuring the sound power. Remember, sound power is about the amount of sound being emitted from a machine. So it's of more interest from an engineering point of view when you're looking at either controlling the noise or just determining from an engineering point of view the characteristics of the noise. So I know that about how they're used. I don't really know the actual technical level of accuracy difference. So that's a good question. Maybe we could look it up.
It sounds like it's in the guts. So, you know, the better the guts, the more precise it's going to be, and you get better data.
Yeah. Okay. Now I put the chat questions, I think, yeah, I put the breakout questions in the chat. Starts with the words breakout questions. So I'm wondering if people can copy that chat. So when you go into your breakout groups, you can copy it into the chat. Let's see, there's one more question. Which one should be compared to the OEL, TWA or LAEQ? Well, actually, we just use TWA to make it familiar to you, because most people know about TWAs for chemicals. But when we talk about noise, we usually don't use that terminology. I know some of the sound level meters do use it, but you'd have to look at what your jurisdiction says. So the OEL is usually in the standards for a jurisdiction. And what you need to look at is usually the 8-hour LAEQ. And when we get to answering the quiz questions, you'll see we gave you some problems where the exposure was not for 8 hours and you have to convert to 8 hours. So that's what you want to look at, is what the equivalent 8-hour equivalent is. So that would be the LAEQ, 8 that Gary showed you in the slide. I have to tell you, if you're talking about what terminology is used in the particular sound level meter, say printout, it can be complicated. And that's why one of the things we want to talk to you about is if you need a kind of an advanced session on interpreting that data, I think we would need to do that in a different session. And you would want to read the manual very closely, because I do find that some companies may change terminology on you for their particular instrument. But in terms of what standards say, they usually express it in terms of LAEQ. I don't know if that helps.
And it may be confusing because in the slides, we had LAEX. So specifically for the, what we call the time weighted average, or the average over the 8-hour shift.
The EX is usually used to mean the worker's exposure, whereas the EQ just may mean the sound level in general. Another source of confusion sometimes. Okay, I'm going to create the breakout groups, and we have Gary, Miriam, Chandra are here. I usually have to stay in the main room, at least for a while. So I might ask if, maybe one of the more experienced people, like I just learned Nadia is, if we can put you in one of the groups, Nadia, that where there isn't another tutor. So I'll create the breakout rooms and may need to shift people around a bit. So hang on a sec. So Miriam is in 1, Gary is in 2. Where's Chandra? Can't find you. So Nadia, I'm moving you to, I think it's room 4. And Chandra, I can't. Did Chandra have to leave? Okay, I don't see him. Okay, well, group 3, Dabby is in there. Ebenezer, I know you have a lot of experience, so I'll probably pop into group 3 if I can. But please copy the breakout room questions so you can put it in your own chat. And what we'd really like to find out is, have you had experience using a sound level meter? Have you tried the cell phone apps? Please, everybody answer that question. Go around in your group so that everybody gets a chance to talk. And we'd really like to know what else you need to know about doing sound level surveys, like that question Ebenezer answered. How do you interpret? I think that might have been a question about how you interpret the data that you might download from a noise dosimeter or a sound level meter. If you need that kind of information, we want to know it. We don't necessarily cover it in the main course, but we could have a special session about it. So I'm going to open the rooms now. Please accept the invitation that you get. And you will have 15 minutes in your room. So the people left in the main room, are you having trouble going into the room? Can you please unmute? Paul, Min, are you having trouble getting into your room? So welcome back, everybody. Good to see you. So we should have a report back. Gary, do you want to do this session? I know you have to leave soon, so I don't know if you want to report on anything or lead the report back. But
It doesn't matter to me. Other than calling out 1, 2, 3, 4, 5.
okay,
How many rooms did we have?
we had 4. We had 4 rooms. Yeah.
Okay, I would just
So-
say. So who was room 1? Who was in room 1?
I think Miriam was. So anybody who was with Miriam, I think it was Miriam's room.
Yeah, it
Any-
was.
Is there somebody who can report back?
There were several of them.
Okay, all right, I'll go for it. So
Thank
the
you.
first question was on whether we have used a sound level meter or the app before. So most of the members in the group, they have used it for college purposes mostly, and more recently, some have also used the NIOSH app, and I think they found it fairly straightforward to use. Some of the team members in our group, they said they have never used, and they are also hopeful that after this course they'll be able to use, especially the app, the NIOSH app, which is fairly easy to download from the app. What was the next question? May someone help me to refresh?
Did you find out the exposure limits in your jurisdictions? Or maybe you can just say if anybody had trouble finding them. In the group I was in, sound like everybody had them, found them.
Yeah, like if even if you use the NIOSH app, it's so straightforward. So I actually have my results in front of me. So yeah, I don't know about the others because we didn't deliberate a lot on the results from our measurements. But yeah, we did. And then the next question.
What do you want to
Excellent.
learn about doing noise surveys?
Oh yes, what do we want to learn? The reasons are varied from some of our colleagues who say that in their countries or jurisdiction, like you call it, there's no regulation either from the government from any other regulatory authorities. But generally they use 85. But they said because noise is one of the most common occupational hygiene exposures or stressors, hygiene stressors in the workplace. They would like to learn a lot more about carrying out noise surveys in order to contribute to general prevention of noise-induced hearing problems in the workplace.
Great, thank you.
Then, yeah, some of us said, yeah, we need to refresh. We have probably done it before, but we need to refresh, especially for interpretation purposes.
Okay, that's great. Thank you. Thanks very much.
Yeah,
Going
pleasure.
on to group 2, I think that was the group that Gary was in.
Yeah.
Is there anybody reporting from your group, Gary?
I forgot to ask, but I'll ask now. Is there anyone who would like to save me from having to talk and go ahead and step up and express yourself? I think we covered all of the questions.
Is there anyone, maybe we don't have too much time from each group. Maybe we should just focus on what people want to learn. Is there anybody from your group who wants to talk about what people would like to learn about doing noise surveys?
Because it was about very similar to group 1 in terms of like someone used the instrument and someone only used the phone, and we're learning to use the app, and be very enlightening. And all of them had an 85 decibel criterion with 3 dB doubling.
Okay, great, thank you. Thanks very much. Dabby, can you report on the group that you were in? Because I know you were there. You're still muted.
Okay.
There you go.
Okay. On the use of the sound level meter, some of us have used it, but some of us also haven't used it yet. So the group was 50-50. Some have used it in the past, but some did not. Some in the university time, some have used during training sessions or something like that. And for the app, most of us have used the app. But again, some of the group members haven't used it, and it was a good catch-up for them to know about the app, and also the limitation with using the app, and the requirement for using it. I think Marianne also intervened on that point. When we decide to use the app, what do we need to do to make it more accurate, like the use of microphone? Okay. For the exposure limit in most of our countries, especially in Africa, we don't have jurisdiction that talks about noise exposure limit. Like I have one of my colleagues from Ghana, and even in my country, there is no legislation that talks about noise exposure limit. So we adopt best practices around the world, like ICGIA, like European standard or OSA standard. So that's what we use. But in some of the countries, some have 8 hours exposure limit of 85 decibels, like in Brunei, and like in Botswana, and so on.
Great.
Yeah.
Great, thank you. And I heard what you said. And people said, well, I was there, so I heard it. So people said they
Yeah.
would like to learn more about doing
Exactly.
the noise
Exactly.
surveys. That's
Yeah.
terrific. Thanks so much, Debbie.
Marine,
Thank
you.
yes, I'm sorry. I have a question that maybe we can, I don't know if it's Gary there, but maybe Marine, you can help us. That it is, how can we establish our program? Here in Peru, our legislation is very, like, doesn't give us that time that we should do the measure in a year. And we, some cases, assume that it must be like once a year. Other companies do it twice a year, but in many workplaces we don't do that. We do that like 3 times a year, or only when we have some controls applicated in our workplace. So what is your recommendation there?
There isn't necessarily a universal rule about that. Usually it's based on the noise level. So certainly if it's above your limit, which I'm hearing is mostly 85 decibels, it's good to do it once a year. Often
As
your
minimum.
standards might say, so if your standard says something, then that's what you go by. But I would say a general rule is if it's above 85, good to do a survey once a year, and then you would probably need a hearing conservation program, and you might be wanting to do audiometry then as well, which we'll get to in another session. Thank you
Okay,
for
thank
that
you.
question. That was great. Okay, the last group was, I think Nadia was in that. Can you report back, Nadia?
Yes, we had a very nice group. It was very interesting. We were all very active and interactive. We basically looked at aspects as to why you do a type 1 and a type 2. I know in South Africa, we are moving away from a type 2, moving towards using a type 1 and to be legislated, because currently now it's allowed to use a type 2 as well as a type 1. So the regulations are actually being readjusted and pushed to a type 1. And the type 1s, from what we've understood, is that it's based on tolerance levels and more so a precision level, whereas type 2s are more so a general sort of a grade of measurements. And then we also had a very nice conversation with Echi and team like Pravina and Tawadza and Sumit. They all interacted very nicely. Echi, I think you want to deliver some sort of feedback as well.
Yeah, thank you. So in my group, we talked about, yes, a lot of us had handled sound level meter. Yeah, and talking about the talking about what we want to learn from the noise measurements. Yes, like example myself, I said the reason what I wanted to learn was to know the noise level around a certain environment so that it will help in giving recommendations as to what to do while working in that environment. Do you need a single hearing protection? Do you need a double hearing protection? Do you need to be enrolled in a hearing conservation program? Stuff like that. So with this knowledge, or with this knowledge of the sound level around that place, you'll be able to give adequate recommendation to your to the personnel working there. Also, the exposure limit in most places has gathered from group members as 85. Although we had some persons with 90 decibels as their exposure limit in their jurisdictions, and also the exchange rates for most of us 3 decibels. So thank you.
Great, thank you, Etchi. That was great, very useful information for us. Nadia, did you want to say anything else?
We also talked about the use as to why we are doing noise surveys and why we want to learn about it as well. Also is to protect worker health and also to maintain compliance. And that's just the summary. A lot of people got confused with the LEX8, trying to interpret the language written. So a lot of them understood that it would be, your time weighted average as well.
Right. Essentially, it's easy to understand it as a time weighted average because we're used to that. I have no problems with using that terminology, but usually the legislation talks about LEX8 or LEQ8. What might help is if you send me, if anybody wants to send to the tutors email, Gmail, WHWBtutors@gmail.com, send in your legislation. I would be interested in looking at that, and because we might be able to help answer those questions. In terms of Ecky's very good questions about what you do at different levels, first I would say is there a legislative requirement? Because in some jurisdictions there is. Like you saw Chandra's response about the action levels. OSHA also in US has an action level. So if your jurisdiction or your company says, if people are exposed to 90, you do this, et cetera, then that's what you need to look at first. But if you don't have that, there may be some good practices, and you may want to look at what, for example, even though I don't like the US standard in that it has a 90 decibel limit, and I think that's too high, I think they have some good things in their standard in terms of what you should do in terms of a hearing conservation program. So maybe we could find for you, maybe what might be a model or an ideal, or help you develop one for your own companies, what might be a good hearing conservation program. So that's something to look at. I'm learning a lot from you, and I thank you all very much for that. I just wanted to make a few comments about the NIOSH app. It's really mainly if you don't have a sound level meter or you don't have one all the time, to use as a screening tool. But sounds like a lot of you have access to a sound level meter, so that's great. You don't need to use the NIOSH app. But if you are using it, please do look at the manual. I sent you the link in the assignment, and it tells you how to make it more accurate. It's more accurate if you use an external microphone with it and if you calibrate it. And if you do that, it's close, not as good as a sound level meter, but close. And you can use it as a screening tool. So if you're doing a walkthrough survey and you just want to get a sense of what the general ballpark noise levels might be, it can be useful for that. And also we usually carry our phones with us more than we carry a sound level meter. So if you're somewhere and you just want to get a general idea of the noise level, it's handy to have that with us. And that's how I use it. I mean, I don't use it professionally when I do a sound level meter survey, but if I'm somewhere and I'm wondering what the noise levels are, you can often tell just by listening, because if you can't hear people talking to you, it probably means the noise is too loud. But it can be helpful to get a general idea of that from the app. So I think these discussions are very useful. I have more slides to share with you, but not too much more time. So I think, maybe we don't need to go through a lot of this detail because it sounds like a lot of you know a lot already, but I will maybe just go through some of this basic material and the quiz questions to see what people missed. But what I'm learning from you is it might be useful for us to have some special sessions that are not formally part of the course, but one is on doing noise surveys and especially interpreting the data from sound level meters and dosimeters, because that is complicated. And if you want a special session on that, we can arrange that. So again, just quickly, and I think a lot of you have experience with this, and this was in the material we sent you, but we often need to add sound levels and decibels. And because we're converting to log scale, it's not just a matter of adding it up. And when might we want to do that? Well, if we're adding different frequencies, sound from different sources or different exposure levels in different time periods. And the formula for doing that looks very complicated, but the general idea is you're taking the decibel, you're converting it back to the actual pressure level in pascals, which is just not a log number, just an ordinary number. So you convert it back to the pascals, you add up all those pascals, and you convert back to decibels. So that's the general concept. But of course, now we can do it with computers. So I gave you a computer spreadsheet. This has actually embedded in the slide deck if you need another copy of it. And I know you asked me, somebody asked me some questions about it in WhatsApp. So hopefully you can use that. But if you have any problems, just ask. There is a rule of thumb for adding, which is pretty simple, which is this table. So if you have two machines, say that they're the same sound level, say you have something that's 85, a machine where it's 85, and another machine where it's 85 decibels. So what would be the total sound? It would be 88. So you just add 3 decibels. We talked about that earlier, if it's double. So I'm going to go through this very quickly because we don't have much time, but as I said, I'd be happy to answer more questions if you want. So when do we use this? Well, when we want to calculate the noise exposure, it gets a little more complicated to calculate that term we discussed earlier, the LEQ or the L average, especially to compare it to the limit. And we already talked about the exchange rate. So here's a link to the calculators. By the way, the one I gave you was from OCAL, which is Ontario, the Ontario Health Clinics for Ontario Workers, which I like a lot, but it uses the Ontario standard, which sounds like that's the same standard most of you use. 85 decibel limit, average limit, 3 decibel exchange rate. But if you're in the US, that won't work for you. So here's one, this one here. There's a link to it. We'll use the US standard, which is 90 decibels and a 5 decibel exchange rate. So here's that one I gave you. And actually, I'll show you about using it for the actual problems we gave you in a minute. And I'll go. So here's those problems we gave you in the quiz. Here's that first one. And mainly what we were getting at here was irregular hours. So many people don't work 8 hours a day and you average the exposure over those 8 hours. They might work 6 hours, they might work 12 hours. And then you have to convert the exposure to the equivalent of an 8-hour exposure and the dose. And that's what that calculator lets you do. So here was that question. And you see 88% of you got it right. So that means about 12% of you did not get it right. So the correct answer was the 8-hour exposure. She was exposed for 6 hours to, I forget what it was, 86. No, it was 88. But what was the equivalent for 8 hours? And the right answer was 86.8. Well, how did we do that? And now, those of you, I'm expecting you to mark your own quizzes and know which ones got it wrong. And if you got it wrong and you want more explanation, please do contact me. So send me an email so we can explain it to you. But, and then second part of that question was, what was the noise dose? And fewer of you got that right. So again, if you got it wrong, please, and you haven't figured it out, please do contact me and find out what you need to do. So here's using that calculator, and I used the second part of the calculator. So I just put, we only have one activity. We don't know what the other one is. So I just put in the exposure time was 6 hours, put in the noise level of 88, and that's how we got the LEQ, which is the number in pink at the bottom, 86.8, and the dose was 149.6. So the calculator is very useful, and I don't really use those formula anymore because I just use these calculators, and they're very simple to use when you know how to do them. So if you're not sure why you got it wrong, please do contact us. So the next question was to show you that a 12-hour exposure, you have to compensate for that. So, oh, I think I needed to change this. I think the problem was 86 dBA for 8. Oh no, sorry, I can't see the thing. I think, yeah. So it was 86 dBA for 12 hours. What is his 8-hour LEQ? If the exposure limit is 85/8, what is his noise dose? So again, he was exposed to 86 decibels, but for 12 hours, so longer than 8 hours. So the actual LEX, his actual exposure, will be higher than 86. And the right answer, and most of you got that, was 87.8. But again, when it came to the dose, most of you did not get it right. No, I'm sorry, most of you got it right, but fewer of you did. So I'm not sure what happened there, but if you got it wrong and you can't figure it out, again, please do get in touch with us. And here's just the way I use the calculator to figure that out. So 12 hours at 86 gives you an equivalent of 87.8 and a dose of 188.8. So hopefully you know now how to use those calculators. So doing noise surveys, this is where we don't have too much time left, but if you're doing a survey, and it sounds like a lot of you have experience doing that, the first thing you want to do is a walkthrough survey to identify areas where, where there's a reason to think noise is too high. If you have a sound level meter, you can use that. If you have a cell phone app, you can use that, or you can just say, can people hear themselves and hear somebody else speak when you're about 2 feet apart, say. And where it is, you need to go back and do a longer survey. So what does that entail? We can do a longer session on that, but you may want to do noise mapping. I'll show you an example of that, and then do measurements at each area and workstation. And then you want to do personal dosimetry. Here's a picture. I think Gary covered that. Whoops, what happened? I don't know if you can see. Can you see my cursor without having to use the laser? Can you see the cursor? Okay, good. Yeah, so here's an example of a dosimeter. You may be familiar with those. This one is a small one that actually clips. The microphone is right on the device. It clips right onto the worker's shoulder. Or you can use one that has a mic that on a wire. So the worker usually puts that in their pocket or clips it to their belt and then clips the microphone on their collar or on their shoulder. And that will measure the noise over, say, a whole work shift or an extended period of time. You want to do it for a length of time that is representative of the whole shift, even if you don't measure for the whole shift. So that's one thing you need to decide. And you need to make sure your settings are right. So I really want to emphasize that. I think the next, key measurement settings. So I've had a problem when somebody went out and did a noise survey and they didn't do the settings correctly. So I know a lot of you are experienced, so this may not be an issue for you. But if you're new to this, please pay attention to the settings on your device, because we once had to throw out a whole survey because they didn't have the right weighting network. For some reason, the weighting network got changed to C instead of doing A. Make sure it's on A. use the right criterion level, which is your exposure limit. And it sounds like most of you are in jurisdictions where the exposure limit is 85. So that's your criterion level. You usually want it on slow response. Often the regulations will say that it must be on slow response. And then you have to look at what the threshold is, which is the lowest level, as Gary explained, that's taken into account in calculating that average exposure. And we generally like to have no threshold. In other words, it will measure all noise. But if there needs to be a threshold level, make sure it's low enough that you're going to get the noise of concern. And again, often your standards and your regulations will say what that threshold must be. So make sure, check the settings. And that's where, if we do an advanced session, if anybody has questions on how you check the settings, we can cover that, but we don't have time to do that now. On the NIOSH app, there are 2 classes of settings. You'll see that, so pay attention if you're using that app. It's either NIOSH or OSHA, and they're different settings. So, because NIOSH uses 85 as a criterion, and the OSHA uses 90. Also, OSHA uses a 5 decibel exchange rate, and the NIOSH uses 3. So if you're, for your jurisdiction, unless you're in the United States, make sure you have that on the NIOSH setting, not the OSHA setting, okay? If you're using that cell phone app. Okay, so here's more about the, I kind of explained that already. Make sure you calibrate, again, if you're using a sound level meter or a dosimeter, make sure you do calibration before and after. You want to make sure if you do it, when you do it after, it hasn't drifted too much. And usually if you're using a sound level meter or dosimeter, it will come with a calibrator, which is set at a certain, gives you a pure tone at a certain frequency and a certain level. And you just stick the microphone into the calibrator and you should adjust it so you get it at the, it's reading at the specified sound level, sound pressure level. So again, make sure you do that. And usually if you have equipment, it will give you instructions for how you do the calibration. How are we doing for time? Okay. So that video I gave you some basics about doing a sound level meter survey. Using a windscreen is a very good idea, especially if you're doing outdoors. Try to avoid where areas where there's reverberation. In other words, the sound is kind of bouncing off walls or of equipment. It will give you inaccurate readings. I don't have time to go into this in detail, but what I'm hearing is people would like an advanced session on this. If you're using a dosimeter, here's some examples of how it can be placed. It's almost always has a windscreen on it. So you generally either want to put it on the worker's shoulder or the collar. And here's an example where that the whole instrument, it's a tiny instrument, and you place the whole thing on the worker's collar, whereas here it's just the microphone you're putting on the shoulder. Now here's a noise map, and I don't think we did this one, but this is the kind of thing you can do. We did this in several places where they wanted this, and what we had was a GPS instrument, and the GPS would kind of, we had it like timed, so we knew the time the GPS instrument was in each location, and we had it logging noise, sound levels, and then after that we gave that to our CAD person, computer assisted design person, and they could match it up, match the sound measurement to the GPS location, and they were able to generate a map that looked like this. So you have a general idea of what the sound levels are in different areas of your plant, and then you will know. So Etchi asked a really good question, what do we have to do in different areas? And this kind of map can really help you. So it will tell you, for one thing, where you need to post signs, because I know at least where I live, if it's above 85 dBA, you need to post a sign saying that hearing protection is required. But whether or not you have to, it's a good idea to do that. It will tell you, you know, what workers you may need to include in your hearing protection program. and where you need to maybe pay special attention to noise control and noise reduction measures. So these are quite useful maps. And then if you're using a sound level meter or a dosimeter, the company will usually provide some software so you can download your readings, and it will do all sorts of neat things. And this is just one example of the kind of graph it can generate it, and could do a lot of other things. And this is where, if you are using this and you want to know how to interpret the results, and you can play around with it, you can do what they call what if scenarios. So if, say, you have a measurement but somebody's working there for 8 hours, you can ask it. If somebody's, sorry, for 12 hours, you can say, if at this level somebody's working for 12 hours, what is their exposure? What is their average? And those are some of the things you can do with the software. So it's very good for generating reports. So this is like, one of the lines will be your average, and one of them will be the maximum, and one will be the minimum level. One little clue is, if you're interpreting this, use the L max, which averages that maximum reading over 1 second. Don't use L peak, because peak is usually, it may be something like somebody tapping the microphone will often get it to shoot up and show a peak that's really, really high. But it's what they call an artifact. It's not really the correct measurement. So generally we look at what they call L max, okay, not L peak. And here's another example of a real graph generated from one of our real surveys about a noise exposure to a particular worker from a dosimeter. So you could see that the exposure varied quite a bit over the day. And then it gives you also, see, that's what Ebenezer asked me, what TWA is calling, it's saying TWA 8 hours. So, and we, as I said, the standards don't usually call TWA. So you need to look at it and see what they mean by that. I think that they will generally mean that is the LEQ, that is the equivalent exposure for 8 hours was 90. But I would just want to check again, that particular software, that particular device, and make sure that's what they mean. And then they also tell you what the dose is. So that's good. So they calculate that right there for you. Okay, we talked about the app, so I don't think we need to talk about that anymore today. Again, it sounds like most of you use the NIOSH one for iPhone, which is great, because I don't feel the Android ones are not, I don't have much confidence in those, because I don't know who's tested them, but the NIOSH one, we know they've done a lot of testing on it. So if you can use that on the iPhone, that's terrific. Okay, some more of those quiz questions. Again, most of you got this right, but so you said, I said, what instrument would you use to measure a worker's exposure over a full shift? So most of you understand it was a noise dosimeter. Now, sound level meter, I wouldn't say that's totally wrong, but it would be kind of difficult to use that for a full shift. You'd have to kind of plant it right next to the worker. If the worker's moving around, it's not that easy. So I would say, if you want a full shift, use a noise dosimeter, which is mounted on the worker, and you're going to get the actual worker's noise exposure. Again, this was using the spreadsheet that I gave you to add some decibel levels, and not everybody got it right. So please do, if you got it wrong, the correct answer was the 93.1. Please go back to that spreadsheet, and here I have it here. So here's what we did. Here, this shows you what I was telling you about how we add. So the 92, this is what we input, 92 decibels. It converts it to pressure, right? So it's converting it to pressure, it's adding up the pressures, and it's converting it back to decibels. So it's actually a lot more simple than the formula makes it look like. And if you don't have anything, I just put zeros in the other space. So I'm not sure what went wrong in some of those calculations, but if you don't understand how to use it, please do ask. And there are other calculators you can use that are online, but you don't even need to use a spreadsheet if you have access to those online. What weighting network would you use? Well, it's definitely A. I'm not sure why somebody thought it was B. There isn't really a B network. So please go check your information if you said it was B, but most of you knew that it was A. And that, right on time. So quite, maybe 1 minute over. So I went through that very quickly because we did not have much time, but I am happy to stay. If anybody wants to stay and ask some questions. Yeah, okay, so Ibrahim said, yes, some sound level meters. Many of them do. Okay, that is great. I also have used ones that measure A weighting and C simultaneously. They also, they have what they call different meters in the device, whether it's a sound level meter or dosimeter. And you can have different settings for the different meters. And that is fine. So you can weighting A on one, some of them have a different exchange rate, some of them you could have a different criterion level, but make sure at least one of them is on, has the settings that you need to show compliance with your standard. So just be careful about that. And when you do the interpretation, make sure that you're looking at the correct, the one that has the settings that you really want. So I agree with you, Ibrahim, that can be very useful. Any other questions? After seeing a slide, I think I just put the info in activity 1. Okay. I see, okay, that's good. Okay, any other questions? Very good. So as I said, I'm willing to stay if anybody wants to say, oh, okay, Ebenezer has another question. The LMAX you will use for the what if scenario. Will it have to be on an A? A. If we're talking about, again, anything related to compliance, you would want to make sure it's on the A weighting network because pretty much all standards are in terms of for human hearing are on an A weighting network. Any other questions? Okay, it sounds like people might want to have a special session on sound level surveys and perhaps using the instruments. So if anybody has some more time or you can send us an email, please do write in the chat or unmute and speak and tell us what you would like to cover. For example, would you be able to benefit from the session on using the software from the sound level meters and the dosimeters and interpreting those results? Anybody?
I have never used a software, so it will be cool to see it.
You'd like to have that? Yeah.
Yes, I have never used it, so.
Oh, you've never used it. Okay.
so.
Many
If
of them
any,
also said
sorry,
that. Many
I'm
of them
sorry.
said that.
I'm sorry, I couldn't hear that. Could you say it again?
I'm saying many of them said that they would be needing that.
Okay. Okay, thank you. Thank you, Mary. Okay, we'll look at doing something like that. Any other topics that you might want to cover in a special session on noise surveys? If a session for octave band analysis, okay, that's good. Does anybody else want that? A session on octave band analysis? You'd like to learn about interpreting the results. Okay, very good. Okay. Yeah, Gary mentioned octave band analysis. We thought it was kind of, we didn't really want to go into it in this class because this is a more of a basic class. But one of the things that you can do with some sound level meters is analyze the sound at different frequencies, which is used for more control measures like hearing protection, engineering controls. So yes, we can cover that. Okay, anything else? Okay, a measurement for a group of workers. Okay. This is all very useful. Good. Thank you. Okay. Well, thank you all. Have a good week. We will be posting, I'm not sure when we'll post the next assignment, but it will be soon. And you have a great rest of the day or evening and a good week and see you next week. Take care.
Thank you.
Bye, everyone.
Bye.
Thanks.
Thank you.
Bye. Thank you, Mary.
Bye. Thank you, Marianne.